So continuing on with 20.3, we're now looking at explain 1, applying the zero product property to functions. And so when given a function of the form f of x equals the quantity of a plus b times the quantity of x plus b, you can use the zero product property to find the zeros of the function. And so if we're looking at a, for this part I want you to just watch. So if we're looking here, we have x minus 15 and x plus 7. And so if we set each of these equal to 0, because each is a part, we add 15 and we get x equals 15. And then we subtract 7 and x equals negative 7. Okay, and so now I want you guys to go ahead and write with me. So you guys are going to do B with me. So f of x equals x plus 1 times x plus 23. And so we know that the first thing we need to do is set it equal to 0. And then we're going to set each part. So we're going to take the first part here, x plus 1 equals 0. I'm going to take my second part here, x plus 23 equals 0. And then I'm going to go ahead and I'm going to solve for x. And so if I subtract 1 from both sides, x can be negative 1. If I subtract 23 from both sides, x can be negative 23. And so the zeros are negative 1 and negative 23. Okay, so pretty simple. We really just take each part and set it equal to 0 and then solve for x. So it becomes a simple equation. So number 2, the discussion. Jordy was asked to identify the zeros of the function f of x equals the quantity of x minus 5 times the quantity of x plus 3. Her answers were x equals negative 5 and x equals 3. Do you agree or disagree? Well, if we go through and we set each part equal to 0, we know that x should equal a positive 5 and x should equal a negative 3. And so we would say we disagree because x equals 5 and x equals negative 3. Okay? For number 3, how would you find the zeros of the function negative 4 times the quantity of x minus 8? Well, again, we're just taking each part and setting it equal to 0. So we have negative 4 times the quantity of x minus 8 equals 0. If we break that apart, we have negative 4 equals 0 and x minus 8 equals 0. Well, we know that negative 4 will never equal 0, and so we really don't need to even worry about this one. And so if I continue on with x minus 8, we add 8 to both sides, and x will be 8. Okay? So for number 3, 1 solution. So for number 4, what are the zeros of the function f of x times the quantity of x minus 12? And so we're going to look at both of these. So we set it equal to 0. We break it apart. So we have x equals 0 and x minus 12 equals 0. So we know that x will be a solution. Or not x, sorry about that. We know that 0 and something will be solutions. And so now we just need to solve x minus 12 equals 0. So we add 12 to both sides, and we get x equals 12. And so we know that 0 and 12 will be solutions for this function because they're the zeros of the function. Okay? So now let's go ahead and look at 5 and 6. So we're going to start with number 5. And so we know that we take each part and set it to 0 after we set the function equal to 0. And so that's our first step. Our second step is breaking it apart. So x minus 10 equals 0 and x minus 6 equals 0. Do I really need the parentheses? No. So I'm going to go ahead and I'm going to erase that step. I'm going to go ahead and do x minus 10 equals 0, x minus 6 equals 0. Well, now I'm going to solve, and so I add 10 to both sides, so x equals 10. I'm going to add 6 to both sides, and x equals 6. And so the zeros are 10 and 6. Okay, and so if we look at 6, we're going to do the same thing. So we're going to set this whole piece equal to 0. So we have 7 times the quantity of x minus 13 times the quantity of x plus 12 equals 0. If I set each part for step 2 equal to 0, I get these 3 equations. Well, we can tell right off the bat that 7 will never equal 0, and so we actually don't need to worry about that because that cannot be a solution. Then we're going to add 13 to both sides because we're looking at our second piece, so x equals 13. And we're going to move on to this equation, x plus 12, so I'm going to subtract 12 from both sides. So I get x equals negative 12. So the zeros are 13 and negative 12. And so that is all we're doing when solving using the zero product property.